Hello students, and welcome to this lesson on circles over arcs, angles, and radians. Our objective today is that we will apply the relationship between central angles and arc measure using our journal notes and practice problems. Now before we get started, we have to make sure that we know what we're talking about as far as arcs and central angles go. And a central angle is going to be an angle whose vertex is in the center of the circle. Now that's important because the center of the circle is a very specifically defined term. So it will always be at one specific point in the circle, and that is the center. And then an arc is going to be a part of a circle or curve. The symbol that we'll use for an arc is going to be this symbol here. So it's just going to be this little curve that we'll put over some letters. So just like we had a symbol for a line or a line segment, now we have a symbol for a arc. Alright, so let's talk about the different types of arcs. So we have a minor arc, and a minor arc is going to be an arc which is smaller than a semicircle. So if we have these points A and B, then we'll call C the center. A to B is going to be a minor arc, and this is smaller than a semicircle. And the name for a minor arc is going to be A to B with our new symbol over it. If we're talking about a major arc, we're talking about something which is larger than a semicircle. So if we choose the same points, A and B again, and we say that instead of going on the shortest path between them, we're going to go and pass through some point D on the other side of the circle, then this is going to be the major arc. And a major arc is always larger than a semicircle. And the way that we would name this is that we would imply that it's moving in the longer path by including D in the name. So we would have A, D, B. Finally, we have the semicircle itself. So if we consider that we have A and B, and they are on either side of a diameter across the circle, then the semicircle will be the arc that runs between A and B along the perimeter. So this is half of a circle. And again, we're going to name this by going ahead and including another point, so we'll include D, and this will also be called A, D, B. Alright, so if we're going to talk about arc length and the measure of the central angle, we'll see that these are going to be very related. So our central angle is just the angle which is formed here with my center being C and then A and B being my points on the edge of the circle. So if we have a 100-degree central angle, then our arc itself, the angle ACB, is equal to 100 degrees. Then the arc AB is equal to 100 degrees as well. Now what we'll see is that central angles are going to sum to 360 degrees, and that makes sense because a circle is an object which is 360 degrees. So if we have multiple central angles here, we have one that is 165, one that is 145, and one that is x, and we're trying to solve for x, we would say 165 plus 145 plus x is equal to 360 degrees. And then we will solve and find that x is equal to 50. Likewise, if I know A to B is a diameter, right, it's a chord which goes through the center, then I am already able to divide the circle into two pieces, into two semicircles, and I know that a semicircle is going to be, so AB, the arc, is going to be 180 degrees. So I don't need to use the full circle then, because I already know something about AB. So then I would say 115 plus x is equal to 180, and I find that x is equal to 65 degrees. Now let's talk about radians and degrees. Radians and degrees are just two different types of measurements. It's like when you're going from imperial units to metric units, right? When you're converting from feet into meters or yards into meters. It's the same thing. They're just two different ways to measure the same type of number, right? And we're talking about angles specifically. So if I'm talking about a radian, radians are defined as how far it takes or how long it takes you to go across a semicircle. So 1 pi is actually the distance that it takes you to go in an angle from 0 all the way around to the other side of a semicircle. So you start at 0 and then you go to pi. So this is pi over 2 would be up here at the top. And to convert from radians to degrees, if you're given some radian, so we say radian, so this is your current number. If you multiply by 180 over pi, then that will give you degrees. Likewise, if we're going from degrees to radians and we're starting with a degree, we multiply by pi over 180, and that will give me radian. Now, we've talked about the arc length as far as a... All right, if we're talking about calculating an actual arc length, so we've talked about how arc length is related to the central angle, where they have this relationship, right, where the arc is going to be the same as the central angle measure. However, we can also calculate pretty much a partial circumference, right? So if we're talking about a small piece that we've created using the central angle, and we'll call this theta in here, and this will be r, and then this will be s. If I'm trying to find the actual distance from here to here, so that actual distance s, I actually have a handy little formula here. So s is the arc length, is equal to the radius times the central angle measure in radians. So this is specifically using radians. All right, so let's see a couple of examples of this. So I'm given that the angle here is going to be pi over 3. This length here is 9 centimeters, and then I'm trying to solve for s. So s is equal to r times theta, and so s will equal 9 times pi over 3, and so we get that s is equal to 3 pi. So that distance there, this distance here, will be s, or 3 times pi. All right, let's do one final example, and then we will go on to our activity. All right, so we have an angle of 145 degrees, and we have a radius of 6 inches, and we're trying to find this S here. And what we found is that we need to have radians to be able to do this. So we need to convert this 145 into radians before we can calculate the arc length. So we convert 145 to radians by saying 145, so my degree times pi over 180 is equal to 145 pi over 180. So this is going to be 29 pi over 36. And so S is equal to now 6 times 29 pi over 36. And so we get that S is equal to, well, the 6 and the 36, those are canceling out a little bit, right? So that'll cancel out. That'll become a 6. So this is S is equal to 29 pi over 6. And this will be in inches. And over here, this is in centimeters. So we've seen two different ways to find an arc length. We have the arc length when we're using our radians, and we have our arc length when we're using our degrees. When we're using degrees, it's just going to be the measure of the central angle. When we're using our radians, it's a little bit more specific, and we have a formula for it. So we say arc length is equal to the radius times the central angle measure. All right, so for your reflection, write one sentence about what you learned today. Write a second sentence to describe how you feel about the material. For your assignment, once complete, ask me for a stamp, and then begin working on your in-class assignment. If you have any questions, let me know. Have a wonderful day. Goodbye.